Hello, I'm Lao Gao. Today we are going to discuss a subject that has been on everyone's mind recently. Japan is releasing nuclear wastewater, but it is more precise to refer to it as treated nuclear contaminated water, rather than the typical nuclear plant wastewater. On August 24th, 10 days ago, Japan's Fukushima nuclear facility commenced discharging this treated water into the Pacific Ocean. The outlet is situated approximately 1 kilometer offshore, with the water being released through an underground pipeline leading to the seabed. This matter has captured international attention, particularly from adjacent nations. Numerous individuals have observed news reports, with some engaging in protests, others stockpiling salt, and some expressing concerns about whether fish, shrimp, and all seafood will continue to be safe for consumption. It's not solely the neighboring nations that are apprehensive. The Japanese populace is also anxious. Japan's opposition parties have criticized the governing party's decision to discharge the water. Japanese fishermen and those within the restaurant sector are worried about their livelihoods. In response, the Japanese government is underscoring the necessity and rationality of releasing this treated nuclear contaminated water. They emphasize that the discharge of this nuclear treated water will not have any health impact on humans. But is this really true? Firstly, there is a fact that the discharge process of this treated water and the water that is subsequently released have all been evaluated and supervised by the International Atomic Energy Agency. Of course, the International Atomic Energy Agency is continuously monitoring this discharge, and the Tokyo Electric Power Company of Japan is constantly reporting the test results. So what exactly are the results? It's still too early to say, as this is something that requires long-term continuous observation. Now, the International Atomic Energy Agency, IAEA, is an international organization independent of national governments. It is a subsidiary of the United Nations, and its main role is to ensure the safe use of nuclear energy and prevent nuclear proliferation. It is also responsible for overseeing nuclear facilities worldwide, making it an organization closely related to the fate of humanity. Now back to the question, does the supervision of the IAEA mean there are no problems? Is it truly safe? Let's take a look at what exactly is being discharged. Japan refers to the water they are releasing as LPS treated water. In Chinese, it is called the Advanced Liquid Processing System. The English initials spell ALPS, coincidentally the same as Europe's largest mountain range, the Alps, hence it is also called the ALPS system. This system is a large-scale filtration setup that removes the majority of radioactive substances from the water through multiple filtration layers. It is crucial to note that it does not eliminate all radioactive substances, just most of them. Especially for tritium, this radioactive substance cannot be completely removed. Of course, tritium itself is very difficult to deal with. In nuclear power plants around the world, the nuclear wastewater they discharge also contains tritium. However, the radioactivity of tritium is not very strong, and as long as it is sufficiently diluted, its impact on the human body is not that significant. Therefore, nuclear power plants in various countries are discharging it. The problem is that the nuclear wastewater discharged by other nuclear power plants generally contains only tritium, whereas the treated nuclear water from the Fukushima plant has directly come into contact with nuclear fuel and contains many other radioactive substances. It is not nuclear wastewater, but nuclear contaminated water. This nuclear contaminated water must go through the ALPS system for filtration, but no matter how it is filtered, some other substances will remain. The Japanese government has not hidden this. They have made it public. For example, it contains cesium-137 and iodine-129, which are radioactive substances harmful to the human body. These substances can accumulate in the body, meaning they continuously remain in the body. Cesium tends to remain throughout the body, while strontium mainly accumulates in the bones, which, if excessive, can lead to bone cancer. Iodine primarily accumulates in the thyroid. Because I secrete thyroid hormones using iodine, if there is radioactive iodine in the body, it can accumulate in the thyroid and cause thyroid diseases. For this reason, when exposed to nuclear radiation, you might have heard about taking iodine tablets. This is to allow the thyroid to absorb the clean iodine first, preventing the radioactive iodine from accumulating there. If it doesn't reach the thyroid, it can be expelled through the body's metabolism. However, this only works for iodine, and it doesn't affect other substances like cesium. In the nuclear processed water, there is another element that cannot be completely cleaned, which is carbon-14. This is something everyone is quite familiar with. When we previously discussed the radiocarbon dating method, it was about the carbon-14 in living organisms. This element is present in all living organisms, and there are trace amounts in our bodies as well. It is almost impossible to prevent because it exists in almost all plants and animals. This is because it moves through organisms in the form of carbon dioxide. So plants absorb carbon dioxide and we exhale it, meaning it could contain carbon-14. However, one not so bad aspect of this element is that it does not. It doesn't accumulate in our bodies, meaning it won't continuously deposit and increase. As I mentioned, when I exhale carbon dioxide, it might be expelled, and through metabolism, it can be eliminated from the body. So even if there are trace amounts in the body, as long as the environmental levels aren't very high, the impact on our bodies isn't significant. However, if nuclear tests cause a rapid increase of carbon-14 in the environment, then it could be a concern. Its impact on our bodies is quite significant because it can't be washed away. For example, if cesium lands on the leaves or skin of plants and animals, we can wash it off. However, this substance can't be washed away, it gets absorbed into the body. Another point to note is that carbon-14 isn't generated because nuclear fuel contains carbon. It's produced due to radioactive materials that emit neutron streams. When these neutron streams react with the air, they create radioactive carbon-14, which disperses in the air as carbon dioxide. Whoever absorbs it will have it in their body. That's the nature of this kind of substance. Well, considering that substances like cesium can persist in the body, is it genuinely acceptable to release them into the ocean in this manner? The Japanese government highlights that they have undergone dilution. Based on their assessments following dilution and release into the ocean, the radiation dose to the human body from these substances is less than 0.003 millisieverts annually. What does this imply? They release the treated water into the ocean. The radiation it generates for an individual over the course of a year is roughly equivalent to the radiation exposure from being on an airplane for under 20 seconds. Naturally, this 0.003 is information supplied by the Japanese government, and its precision can be questioned. Nonetheless, at present, no third-party nation is able to offer more impartial data, so we must rely on this information for the time being. This 0.003 microsieverts is approximately equivalent to 1/30,000th of the natural radiation a person absorbs from food annually. Speaking of this topic, I must mention that numerous individuals are unaware that there exists a substantial amount of radiation in our natural environment. This is referred to as natural background radiation, and it is entirely unavoidable. Regardless of whether you reside in a bustling city, a picturesque suburban area, a war-torn country, or even a deserted location, as long as you are on Earth, you will be exposed to some degree of radiation. Naturally, the radiation levels vary slightly in different regions. Some areas possess higher levels, while others have lower levels. But on average, according to the results published by the United Nations Scientific Committee in the year 2000, each person's annual radiation dose from natural sources is approximately 2.4 millisieverts. This radiation mainly comes from air, soil, building materials, food, and water. So, looking at it this way, the radiation from Japan's nuclear-treated water is about 1/10,000th of natural radiation. Well, why is there radiation in the natural environment? Even though we may not be exposed to any specific radiation sources, why is there still radiation? There are several sources of natural radiation. One is the universe. The universe has many high-energy rays that reach the Earth, and they react with the atmosphere to produce various radioactive substances, such as carbon-14 and iodine-129. Another source is the Earth itself. When the Earth was formed, it contained many radioactive elements. However, over the course of 4.5 billion years, which is the Earth's lifespan, most of these radioactive elements have decayed. Most no longer exist, but some with long half-lives still remain. For instance, uranium-238 has a half-life of 4.5 billion years, so even after 4.5 billion years, it has gone through 10 decay cycles, yet a lot still exists. Thus, when digging, you might find some radioactive minerals. Also, the mineral water we drink must be tested to ensure it doesn't contain radioactive substances, as it would be harmful if ingested. Additionally, building materials made from soil and other materials dug from the ground also need checking for radioactivity. We also need to check for radioactive substances. Besides that, volcanic eruptions and tectonic movements can bring some radioactive elements from the underground to the surface, which we might encounter in our daily lives. Apart from these purely natural sources, the remaining natural background radiation is man-made, resulting from human activities that leave radiation residues on Earth, forming the natural radiation we are exposed to every day. For example, nuclear tests. Everyone knows that the United States conducted many nuclear tests from the 1940s to the 1960s. As mentioned in the film Oppenheimer, they conducted these tests quite casually. Then you detonate a nuclear bomb, and the huge mushroom cloud will push the nuclear material into the atmosphere, causing nuclear pollution. However, with rain and clouds, it spreads around the world and may eventually fall to the ground or into the ocean, but their half-lives can be very long. For example, as mentioned earlier, cesium-137 has a half-life of about 30 years, so from the 1940s, 1960s to now, it has been about 80 years, meaning it has gone through 2 or 3 half-lives, but a lot still remains, right? At that time, nuclear tests were conducted quite casually. One reason was that tensions between countries were high, leading everyone to research nuclear weapons. Another reason was that the understanding of nuclear pollution was not very advanced at that time. The focus was more on survival rather than considering the issues of nuclear pollution, which ended up affecting future generations. Besides these nuclear tests, there were also significant incidents like the Chernobyl and Fukushima nuclear power plant leaks. Both Chernobyl and Fukushima experienced severe explosions, which released pollutants into the environment. The so-called air and ocean will ultimately cause an impact lasting decades or even thousands of years. So natural radiation is actually caused by 2 parts. One is the purely natural environment, which we cannot control, whether it comes from the universe or is inherent to the Earth. What we can control is the part of natural radiation caused by humans, which includes nuclear tests and nuclear accidents. Besides natural radiation, which is about 24 microsieverts annually, another potential radiation source we might encounter in our daily lives is CT scans. This is actually the largest radiation source. A CT scan, just a head scan, is equivalent to your annual natural radiation dose, about 2 to 4 millisieverts. If you undergo a full-body scan, it is approximately equivalent to 10 years of natural radiation exposure, over 20 millisieverts. Many people might not know the relationship between CT scans and X-rays. X-rays, in fact, have less radiation than CT scans. They provide a single image, forming a 2-dimensional picture to show where there might be issues in your body, whereas a CT scan continuously presents cross-sectional images. So the radiation level is quite high. It forms a 3D image showing what your body looks like. Though more advanced, its radiation level is much higher than an X-ray. A chest X-ray is only 0.1 microsieverts, and a dental X-ray is even lower, at 0.05 microsieverts. CT scans and X-rays are in hospitals, and if you don't visit the hospital, there's generally no issue with this kind of radiation. If you avoid the radiology department, there's no problem. You've probably noticed that the radiology department is usually off limits to the public, right? That area indeed has some radiation. Another significant radiation source is flying on airplanes, as I mentioned. When you are flying for a duration of 1 hour, you absorb approximately 0.01 microsieverts of radiation. Flying for a period of 10 hours is roughly equivalent to undergoing a chest X-ray. Therefore, pilots, flight attendants, and frequent flyers are indeed at some risk. They are not necessarily more prone to radiation, but they must inevitably receive this radiation exposure. Additionally, nuclear power plant workers and miners have more opportunities to come into contact with radioactive substances. Furthermore, individuals who are employed in elevated mountain regions are more frequently exposed to cosmic radiation. Nevertheless, in our everyday lives, we generally do not encounter this, correct? The radiation we are more likely to encounter is natural radiation, as well as from airplanes. Natural radiation is not always external. It is similar to rain that adheres to you within the environment. Nearly half of the radiation exposure originates from our dietary intake. Our food inherently contains a specific level of radiation. Based on data from Japan, the radiation we absorb on an annual basis from radioactive substances in food is approximately 0.99 millisieverts, which is roughly comparable to undergoing a chest X-ray once every month. This is attributed to the trace amounts of these radioactive substances present in the food. Radioactive substances are unavoidable as well. The radioactive elements in food mainly come from natural sources and some man-made nuclear pollution, as I mentioned earlier. So, the conclusion of today's video is that the harm from nuclear-treated water might be completely imperceptible in the short term. Of course, you might wonder if fish and shrimp can pass it into our bodies through accumulation, but even if they do concentrate it, the amount is diluted to a level that might not be as severe as taking a flight or undergoing a CT scan. But this definitely doesn't mean that the treated water from Japan's nuclear pollution discharge is without problems. After all, it originates from a nuclear leak accident, which is the most impactful thing on a global scale. The influence from that nuclear accident years ago can cause changes in the annual natural background radiation. For instance, if a nuclear power plant suddenly leaks this year, then starting this year, everyone on Earth will experience a slight increase in natural background radiation each year. This is actually the area with a more significant impact. Therefore, what we should focus on is how to prevent it. Continuing with nuclear tests, how can we prevent nuclear accidents from happening again? Well, everyone knows that Japan's nuclear accident was caused by a natural disaster, which I can understand. However, why build a nuclear power plant in a location where natural disasters might occur? That's indeed difficult to understand. A few days ago, I introduced a film regarding the Nankai Trough earthquake, which highlighted that the location where Japan's tectonic plates converge is now identified, correct? They are aware of where earthquakes are likely to occur, and that these seismic events are periodic. Nevertheless, they still opted to construct the Fukushima nuclear power plant directly across from this tectonic plate junction. They claim to have constructed a seawall capable of preventing tsunamis of several meters in height, but then the tsunami arrived. Regardless of how elevated you construct it, the tsunami will inevitably reach that height, correct? It is advisable to construct it as high as feasibly possible. Otherwise, I believe it might be more prudent not to construct a nuclear power facility at all. Although utilizing nuclear energy appears to conserve a certain amount of coal and seems to safeguard the environment by not releasing pollutants, the advantages are minimal when compared to the catastrophic consequences of a nuclear disaster, which elevates global natural background radiation levels. Isn't that truly terrifying? After all, this matter is closely related to the fate of all humanity, not just Japan's problem. If you know the threat and still choose to proceed without being able to guarantee absolute safety, I think that is a form of responsibility. Even if you handle the nuclear wastewater well afterward, I believe it cannot make up for this issue. Conversely, for ordinary people, avoiding eating fish or salt can only reduce natural radiation to a limited extent. In fact, flying less and having fewer CT scans might be more effective. The effect might be a little better. Of course, there is certainly a psychological factor at play where some people might feel that seafood is slightly risky now and choose not to eat it, which I completely understand as it is everyone's personal choice. However, the key issue we need to focus on is how to prevent further nuclear proliferation and nuclear pollution. This is something that every country in the world, especially the Japanese government, needs to deeply reflect on. Well, let's stop here for today. See you next time. Bye.